Okay guys, today's topic is arithmetic progression. So today's topic is arithmetic progression. So you are already familiar with the sequence of numbers. Suppose a sequence. What is a sequence? A sequence of numbers is arrangement of numbers which in a definite order which follows some rule. A sequence is nothing but an arrangement of numbers in a definite order which follow some rule. Suppose 1, 8, 27, 64, etc. We can easily find out the next term if we know the pattern what it follows or the rule what it follows. So if you see the first term 1 cube, the second number that is 2 cube, they are all cubes of natural numbers, 3 cube, 4 cube, then the next term will be 5 cube, that is 125, and so on. In the same way, we can have another sequence 1 by 4, 1 by 9, 1 by 16. Now you can say what will be the next term? Yes, it will be 1 by 25. Okay, so the pattern it follows is 1 upon n square, that is 1 square, 1 upon 2 square, 1 upon 3 square, 1 upon 4 square, and so on. So, such kind of numbers which follow a pattern or a definite rule are called sequence. Now, what about this sequence? 1, 4, 7, 10, 13, 16, and so on. Can you tell me what rule it follows? So in this, if you see the first term is 1, second term is 4, third term 7, fourth 10. So let us name it as A1. This is A2, A3, A4, A5, the fifth term 13, A6, the sixth term 16. Now in this, A2 is equal to 1 plus 3. A3 is equal to 4 plus 3. A4 is equal to 7 plus 3, 10. A5 is equal to 10 plus 3, 13. And A6 is equal to 13 plus 3 equal to 16. So here we are adding 3 to get the next term. Again, to get another term, we are adding 3 to the previous term. So every time we are adding 3 to get a next term or the successive term. So a sequence A1, A2, A3, A4, An is called an arithmetic progression. A sequence A1, A2, An is called an arithmetic progression if constant number d such that A2 is equal to A1 plus d, A3 is equal to A2 plus d, A4 is equal to A3 plus d, and so on. An is equal to An minus 1 plus d. Here, the constant d is called the common difference. Here the constant d, every time we are adding d to get the successive term. So A2 is equal to A1 plus d. To get the next term A3, we are adding d to the previous term A2. So A2 plus d. So this constant number d is called the common difference. So in the example, 1, 4, 7, 10, 13, 16, dot dot dot. 1 is called the first term. First term is equal to A1 is equal to 1. Second term A2 is equal to 4, A3 is equal to 7, A4 is equal to 10, A5 fifth term is equal to 13, A6 is equal to 16, and so on. So A2 is equal to 1 plus 3 is equal to 1 plus 6. This is equal to 1 plus 9, this is equal to 1 plus 12, and this is equal to 1 plus 15. You can write. Further, this can be written as 1 plus 3 into 1, 1 plus 2 into 3, 1 plus 3 into 3. This one can write as 1 plus 4 into 3. This one can write as 1 plus 5 into 3. This further, you can write 1 plus 1 into 3. This is 1 plus this 2 we can write in terms of 3 as 3 minus 1 into 3. 1 plus this 3 you can write as 4 minus 1 into 3. 1 plus this 4 we can write as 5 minus 1 into 3 plus 1 plus 6 minus 1 into 3, and so on. So like that you can go for An. An is equal to 1 plus n minus 1 into 3. An. Nth term. Sixth term we are writing as equal to 1 plus 6 minus 1 into 3, where 3 is the common difference. And so in the same way, An कैसे लिखेंगे हम? An is equal to 1 plus n minus 1 into 3. So here 1 is the first term and 3 is the common difference. Is the common difference. The first term is denoted by A and common difference denoted by D. If you denote the first term 1 as A and the common difference 3 as D, then An is equal to a plus n minus 1 into d. Thus, we get the nth term as a plus n minus 1 into d. This nth term is also considered as the general term of an AP. Thus, the general term of an AP is given by an is equal to a plus n minus 1 into d, where a is the first term of the AP and d is its common difference. Example: find the seventh term of the AP to 7, 12, dot dot dot. Now we need to find out its seventh term. Here a, the first term, is equal to 2 and d is equal to t2 minus t1. Second term minus the first term, 7 minus 2 is equal to 5. We get d, the common difference. 2 plus 5 equal to 7. Now, we want to find out seventh term. Then we know the formula an is equal to a plus n minus 1 into d. So a7 is equal to a is 2 plus n is 7 minus 1 into d is 5. So we get 2 plus 7 minus 1 is 6 into 5. So 2 plus 30, and that is equal to 32. So therefore, the seventh term of this AP is 32. Now, there is a here if an is equal to a plus n minus 1 into d is a linear expression in n, then it is a term of an AP. Example: an is equal to 3n minus 2. It is a linear expression in n. So it is a term of an AP. Further, in this case, the coefficient of n is the common difference. That is, here it is 3. That is 3 is the common difference. Here in this example, the nth term is given by 3n minus 2. It is a linear expression in 3, in n. Okay. Then, in this case, the quotient of n will be the common difference. So here 3 is the common difference, and if nth term is a linear expression in n, then it is a term of an AB, arithmetic progression. This you must remember. Okay. Further, let us find out the nth term of an AP from the n. The rule to find out the nth term of an AP from the n. Nth term of an AP from the n. If A1, A2, AN, AM is an AP having m terms. If A1, A2, A3, AM is an AP having m terms with A1 equal to A, the first term, and common difference as B, then if A1, A2 up to AM is an AP having m terms, total m terms, with A1 as the first term A and common difference B, then the nth term of this AP is given by, it is given by AN is equal to A plus m minus n into D. The nth term from the n, nth term from the n. Nth term from the n. Nth term from the n of this AP is given by AN is equal to A plus m minus 1 into D. This result also you must remember. Now, after this, let us have another result. Another important result. If m times the mth term of an AP is equal to n times the nth term, then it's m plus nth term is 0. So try to understand. If m times the nth term of an AP is equal to n times the nth term, then its m plus nth term is 0. Next result, if the nth term of an AP mth term of an AP is 1 by n, and nth term of the AP is 1 by m, then its mth term is 1. This is another result which you must remember. If mth term of an AP is 1 by n and nth term of the AP, same AP, is 1 by m, then mth term of the AP will be 1. Then next result, if pth term of an AP is q and qth term of the AP is p, then its nth term will be dash. What will be the nth term? It will be equal to p plus q minus n. So if pth term of an AP is q and qth term of the AP is p, then its nth term will be given by p plus q minus n. So these are few results which you must remember. Now let's see how to select a given number of terms or a set of terms. In an AP. To select the terms in an AP. If we want three terms, to select three terms in an AP. Firstly, three terms in an AP. The three terms in an AP can be selected as A minus D, A and A plus D. 1, 2, 3. First term, second term, third term. Where A is first term of the AP, and D is common difference. A is the first term and D is the common difference. Then A minus D, A and A plus D can become the three constitutive terms of an AP. If you want to select four terms, then the terms can be selected as A minus 3D, A minus D, A plus D and A plus 3D. 5 terms. So 5 terms can be selected as A minus 2D, A minus D, A plus D and A plus 2D. 6 terms if you want to select in the same way. A minus 5D, A minus 3D, A minus D, A plus D, A plus 3D and A plus 5D. So in this way we can have the terms, a group of terms to be selected in an AP. Next up what we must know is arithmetic mean. Arithmetic mean क्या? If A, B, C are in AB, then the common difference B minus A will be equal to C minus D. If A, B, C are in AB, then B minus A is equal to C minus D, or B plus B is equal to C plus A. That implies 2B is equal to C plus A. So here B is called, this implies B is equal to A plus C by 2. So here B is called the arithmetic mean. Of A and C. So arithmetic mean of A and C is given by B is equal to A plus C by 2, and thus B is called the arithmetic mean of A and C if A, B, C are in AB. Let us now go on and find the the sum of n terms of an AB. Sum of n terms of an AP, we know very well, it is given by Sn is equal to n by 2 into 2a plus n minus 1 into d. We already proved this. This further can be written as n by 2 into 2a, you can write as a plus n minus 1 into d, n by 2 into a plus an. This is a plus n minus 1 into d, that is the nth term. So a plus the nth term. So nth term we can consider as the last term. So n by 2 into a plus l, where l is equal to last term or nth term. So we got the formula for the sum of n terms of an AP. Now let us find out Sn minus Sn minus 1. Sn here is equal to n by 2 into 2a plus n minus 1 into d, and Sn minus 1 is equal to n minus 1 by 2 into 2a plus n minus 2 into d. N minus 1 minus 1 is n minus 2 into d. Okay. Now let us find out the difference. We want Sn minus Sn minus 1. Let us find out the difference. Minus here. So we get Sn minus Sn minus 1 is equal to n by 2 2a plus n minus 1 into d minus n minus 1 by 2 into 2a plus n minus 2 into d. Let us find out the difference. What is the difference we are getting? Sn minus Sn minus 1 is equal to, multiplying that, n by 2 into 2a plus n minus 1 into d, we get na plus n by 2 into n minus 1 to d minus n minus 1 into a, 2 gets cancelled, and plus minus n minus 1 into n minus 2 into d by 2, which is what you get. So this is equal to, so we got a common, taking a common here, we get a into n minus 1 plus, now in these two, we have got n minus 1 into d by 2 common, n minus 1 to d by 2 common, then we are left with n here minus n minus 1. N minus 2. Sorry. Now, let's simplify it further. N minus n plus 1, so n gets cancelled, a into 1 plus, this is n minus 1 into d by 2 into n minus n plus 2. So, what is left is 2. This is equal to a plus 2 gets cancelled, n minus 1 into d. Now we know a plus n minus 1 into d is an. So that is equal to an. Thus, an is equal to Sn minus Sn minus 1. So nth term of an AB is equal to the difference of the sum of n terms and the sum of n minus 1 terms. So with this, we conclude the arithmetic progressions. Thank you all of you.